everyone, welcome to Knowledge Center. In this session, let us understand how to solve the problems related to hydropower plant. So I have taken one question related to the hydropower plant, and let's see how to plot hydrograph, flow duration curves, and how to find out the power can be generated using this information of hydropower plant. So this question says that the mean monthly discharge at a particular site is given. So they have given a table in which they have given the monthly discharge of water. So in January, February up to December, they have given the discharge of water in terms of cubic per second. Using this, they are asking you to draw the hydrograph. So as we all know, hydrograph is nothing but that is a graphical representation between the time with respect to the flow of discharge or a flow of water. So now we need to plot that curve here. So already I have plotted it. Now let me explain you how to plot the hydrograph using the given table. So x-axis has to be with respect to the time. It may be a time in terms of a days, in terms of a weeks or a months. Here it has been given in terms of a month. So I have written Jan to December. January, February, March up to December. 12 months have been given on x-axis. And here I have given the cubic meter per second, the discharge of water or a flow of water is given. Now in the month of January, we have the discharge of 200. So we need to point 200 is here and January is here. So we get 1 point here. So just join it. That is 200. Same way, in the month of February, we have 400. So I just highlighted the points. First you need to highlight the points now. In the month of March, it is 600. So 600 in the March. So next what happens? We have 2400 in the month of April. In the month of April, we have 2400. So in the month of May, we have 1200. Okay. So in the month of May, we have 1200. Next, we have 2000 again, 1800 in the month of June. So on. So we just go on, highlight the points. Go on ticking the points and then just join the points as I have shown here. So this is about the hydrograph. How to plot a hydrograph by the given circuit. Now let's have a look over the flow duration curve. To plot the flow duration curve, we need to have a table where it has to give the percentage of time. Here it is given in terms of months, whereas flow duration curve is going to be a plot with respect to the percentage of time, and in y-axis it will be a discharge. So now let's have a look over that, how to calculate the table which will give the percentage of time. To plot a flow duration curve, we need to have a flow duration table as I have written here. Now let me tell you how I got this flow duration table. So this flow duration table is obtained by the given table, given data. So here they have given it in the form January to December. But when you deal with a flow duration curve, it will be in terms of a percentage of time. So we need to identify the percentage of time here. So we should have a table like this. Percentage of time and the duration in months, because they are given in months, so I will take it as a duration in months. If it was in terms of a days, you can take it as duration in days. And then cubic meter per second, this is nothing but a discharge. So what you need to do is, first you need to write the discharge. So discharge, you write it from the minimum to maximum. Because you look into this table now, 200 is the discharge of water in the month of January. Whereas in month of February it is 400. But I can say that in month of February also I am getting 200, minimum 200. This 200 is available in every month. Okay, because in every month it is more than the 200. So 200 is available in all the months. So first I will write that. So what hint I can give here is, first write this discharge in terms of an ascending order. Right, smaller to larger. Right, so what I did, 200, and then what is the next number is 400. And 400 is, we have this for 2 times. But no need of writing it twice. In this particular year, the 400 discharge is there for 2 months. One is February, another one is December. But you write it once here. That's enough. Then 600. It is there for March, so I written 600. Then what is the next least number? 800. Write that 800. Next 1200. So 1200 is also there for thrice, 3 months. But it is there available in 3 months. So just write one number over there. Right. So that is what you need to write. Discharge with respect to, not with respect to the month, with respect to the minimum to larger value. And if it is repeated, write it once. Then 1600 is there here. Then 1800, 2000, 2400. I have written it. It is not mandatory that you should have 12 discharges here. See 1, 2, 3, 4, 5, 6, 7, 8, 9. Remaining 3, it is repeated. The same numbers are there. So I am writing it once. So that is first thing you need to do in a flow duration table. Write the discharge in a ascending order. If it is repeated, write it once. Then duration in months. So now this is important. 200 is the discharge, and that discharge is available for all the 12 months because that is the minimum one, and in the other months also we have more than 200. So 200 will be there. So I have written it as it is there for 12 months. Same way 400. See, 400 is not available in January. In the month of January we have only 200 discharge cubic meter per second, right? So 400 is available in February, and in all other months it is more than 400, right? In all other months it is more than 400. In December it is equal to 400. So just in January we don't have it. So remove that, minus 1, we will get 11 months. In all 11 months we will have the 400 cubic meter per second as a discharge of water. Then 600. So 600 is not available in these two. So we have to remove those 2 months. And is there any other? Yes, here also we have 400. Here also you will not have a discharge of 600. So in 3 months you don't have it. So in a year, 3 months we don't have 600. So 12 minus 3, 9. So in 9 months we will have that discharge of 600 cubic meter per second. That is how you should write it now. So now look into the 800. So it is available for all of the months, but it is not there in Jan, Feb and March, even in December. Minus 4. So we get 8. It is available in 8 months. So you should write the months in which that water flow is available. Okay. Similarly, I have written it for 1200, 16, 2400. So look at this, 2400. In this table, we have 2400 only in April. In the rest of the months, it is less than that. So only in 1 month we have 2400. That's what I have written here. In 1 month, 2400. So this is the next column, the most important column. Now the last column is important for us to plot the graph. So that is percentage in terms of time. Percentage of time. See, now we know maximum duration is 12 months. We have total 12 months. In that 12 months, 200 is there for all 12 months. So you should find the percentage. What is the percentage of 200? It is there for each and every month. So it is there in all the 12 months. So we can say 100%. Or you can just divide it by 12. Divide it by 12. Whatever the availability we have, divided by total number of months. That will give the percentage. So 12 by 12 is into 100 is 100%. So 11 by 12. You will get 91.66 into 100 you have to do to get the percentage. So 9 by 12 into 100. So you will get 75%. Same way, 1 by 12 into 100 we get 8.33%. So this is how I have written the percentage here. I hope this is clear for you. So if that is clear, now we need to plot it. So how to plot it? Take this percentage time in the x-axis and cubic meter in the y-axis. So what I do, it is there from 0 to 100%. So I will write it as 10, 20, 30 up to 100 in x-axis. And in y-axis I will write this capacity, storage. So 200 to 2400. Now first you plotted this one. So flow duration curve is nothing but it is a descending order. So what is the maximum flow here? 2400. Now plot it in a reverse direction now. Plot it in a reverse direction. I have written the table in a ascending order, but the graph has to be drawn in a descending order. So first I should plot 2400 and the last I have to plot 200. So 2400 is there for only 8.33% of duration. So in this 10 we may get somewhere here 8.33. So 8.33 and this is 2400. So you get a point here. Just have a point over there. Then 16.67. 2000 is there for 16.67%. So find 16.67 somewhere here and this is 2000. So just point out these points over there. So 25% is of 1800. So 20, 25. So 1800 will be somewhere here. So you will get the points like this. You just go on adding the points, you will get the curve. So this will be the graph. So hydrograph and flow duration curve graph, there is one small difference. In hydrograph we have just plotted the curve with respect to the months, but here we are plotting it with respect to the percentage of time. So smallest percentage to largest percentage. Now we can say this 200 is there for 100%. It is there for 100%. We'll get it like this. So all months will have the 200 capacity, 200 discharge of water. Okay. I hope this is clear for you. Here I think you have understood how to plot an hydrograph and how to plot a flow duration curve. Now we will find out how to find out the capacity, how to calculate the capacity of power generated using this water. Now let's have a look over that. Now here also we can find out the power generated by using this quantity of water. So in the month January to December, they have given the quantity of water. Using this formula, we can find the total power generated in that particular year. So the power can be given as QHW efficiency into 9.8 into 10 power minus 3. So if you do this, you will be getting it in terms of kilowatt. So now what is this Q? Q is nothing but that is a flow of water or average flow of water or a discharge of water in the particular duration. H is nothing but the head of the dam. So from what height it is going to fall down. So that is head of the high water. W is nothing but the mass of the water. So 1000 kg is a general value we have to take. This is an efficiency of the power plant. 9.81 is considered. It is 9.81 because of the gravity. When it is falling with respect to the gravity. So consider those parameters and get the answer. So here head is given in a question as 90 meters. It is given in the question. And the efficiency of the plant is also given as 80%. So those two are known. W is a standard, that is 1000 kg will be the mass of water. So now only the thing you have to find Q. So Q is nothing but the discharge of water or a flow of water. So here Q is given. This is the discharge of water. But it is given with respect to the month. So we should get an average discharge of water. So how to get the average? Add all this and divide it by total number of months. So 200. So we can do it as 200 plus 400 plus 600 plus 2400. Write all the numbers here up to this. Okay, up to 400 and whole divided by 12. So that will give you the average flow of water. So by doing this, by adding all this and dividing it by 12, we get it as 1150 cubic meter per second. This is the value of Q. So once we obtain the value of Q, you can just substitute it and identify what is the total power generated in that particular year with respect to the given data. So now we can say the P is equal to, the Q is 1150 into head is 90 meter and water is 1000, weight is 1000, efficiency is 80%, so I can write it as 0.8 into 9.81 into 10 to power of minus 3. So by simplifying this, we get a number like 812268. You just calculate it, 812268 in terms of kilowatts, because it is in kilowatts. So the power generated can be given as 812268 kilowatt. But generally we give these power ratings in a megawatts. So convert that into megawatt. Therefore I can say the power developed will be 812.268 megawatt. 812 megawatt per year can be generated using this flow of water. Okay, 812 megawatt can be generated. So using this flow of water. So this is how we can identify how much of energy can be calculated using the flow of water. Okay, another way you can go in reverse manner also. If you want to generate this much of energy, what should be the flow of water you need to get? Okay, using this formula you can achieve it. I hope it is clear for you. Now let's move for the next question. In this problem, they have given the information and asked you to find what would be the rate of fall of water at the end. So look at the question here. A hydropower plant is supplied from a reservoir having an area of 50 km square. So the reservoir is there. Before the dam, we will have a reservoir, and that reservoir is having an area of 50 km square. 50 square kilometer. So that area we call it as a catchment area. So through which the water has been stored and from where we are getting the water. That is called the catchment area. Area is given where the water has been stored, and head of the dam is 50 meter. Head is given, so I written it. And then if the efficiency of the plant is 60%, then find the rate at which the water level will fall when the station is generating 30,000 kilowatt. So they are asking you to find the rate at which the water level will fall. So you need to find rate of fall of water. So rate of fall of water is nothing but how much of water is falling per second. That is the meter per second. So you have to find meter per second. But we know that the flow of water is cubic meter per second. So we can easily find the formula for that. So Q is a cubic meter per second divided by area. Means I will take the flow of water, discharge of water divided by area. That will be the formula to find the rate of fall of water. Discharge of water is given in cubic meter per second and area is given in meter square. So when the meter square and cubic meter get cancelled, we left out with only meter by second. Okay. So this is the formula for finding the rate of fall of water. So just you need to know what is area. Area is given already, 50 km square. This you need to know what is Q. So to find that value of Q, that is the discharge of water, we are going to make use of this formula, that is power. So we know power is equal to QWH efficiency into 9.81 into 10 to the power of minus 3. Now let me write all this information given here. So head is given as 50 meter. From the question I have written it. Density of water will be 1000 kg per cubic meter. It is fixed, it's a constant value. So water density will be 1000 per kg per cubic meter. Then the power generated is given in this question, that is 30,000 kilowatt. It has been written here, and the area is of 50 km square. Let me write it in terms of meter square. So 50 into 10 to the power of 6 meter square. Now I substitute this in the formula. I got the power, but I want to find Q. So what I can do here, Q is equal to the power 30,000 divided by all of the parameters. So I substituted all the parameters here. 1000 is the weight of the density of the water. This is 50 is the head of the plant. 0.6 is an efficiency, and 9.81 into 10 to minus 3. Once you simplify, you get Q, 101.9 cubic meter per second. So this is a Q value. But I don't want the discharge of water. They ask you to find the rate of flow of water. So what I do here is Q by A. That's what you need to do. So 101.9 by 50 into 10 power 6 meter square. I want it in terms of meter square. So I written it as meter square. Now what I will get, this cubic meter by meter square will get cancelled, left only meter. So meter per second. This is what the answer. If you simplify that, you will get an answer. But let me write it in terms of a millimeter by per hour. You can write it in terms of a millimeter per hour. So what I did here, the same value, I'll just multiply it by 3600 and 1000. So why I did this? Let me tell you. So meter has to be converted into millimeter. So I have to multiply it with 1000. When you multiply this with 1000, you will get it in terms of millimeter. And seconds has to be converted into hours, so multiply it with a 3600. So this result is multiplied with 3600 and 1000. Then I can write the unit as millimeter per hour, or you can just keep it as meter per second. If you convert it, you will get it like this. This is the answer for a rate of fall of water. I hope this is clear for you.